This video connects the ideas of square roots and imaginary numbers to quadratic equations. Let's begin with a definition for square roots. The square root of 4, if you were to enter this on a calculator, would give you 2. And the definition, or how we determine what that square root is we're looking for a number that when squared equals 4, or a number that multiplied by itself equals 4. So of course we can see that 2 does meet those requirements, so that would mean that 2 is a square root of 4. However, there is a second number which also meets that definition. So notice that if you were to square negative 2, or in other words multiply negative 2 times negative 2, you would also get positive 4. So we have to make a choice, and for calculators they'll only display this positive answer rather than negative when actually there are 2 square roots of 4. So first of all, notice that this is true. Every positive integer, every positive integer has 2 square roots. And as another example, for 100, there are 2 numbers that when multiplied by themselves or when squared equal 100. You have 10. 10 squared is 100. Or negative 10 squared is also 100. Right? So those are the 2 answers. And in general, when you just see this notation square root 100 or square root of 4, the answer that we're looking for is the principal root. Right? So one of those 2 square roots, the positive one, is called the principal root. Right? And that's what's meant or implied by seeing this notation. Right? Now, the second square root does make a difference when we talk about square roots in the context of solving quadratic equations. So if you see the instructions solve x squared equals 4, then we're looking for all solutions or all numbers for x that make this equation true. So now I would have 2 answers. X could be 2, or it could be negative 2. And a lot of times we'll write x equals plus or minus 2. Right, so here we want not just the principal square root, but we do care about the other one as well. Right? So that's an explanation for the solution based on the definition of square roots. There's also an explanation for these solutions based on the connection to parabolas. So if I were to rewrite this equation in standard form, I would subtract 4 from both sides, and we'd have the equation x squared minus 4 equals 0. So the connection to parabolas is that solving x squared equals 4 is the same thing as looking for the x-intercepts of x squared minus 4. Right? Or in other words, I want to know, if I look at the parabola y equals x squared minus 4, where does it cross the x-axis? Where is that y value is 0? So graphically, I'm going to pull up a picture of the graph here. I've graphed y equals x squared minus 4 on Desmos, and you can see that there are 2 x-intercepts, 2 places where it crosses the x-axis. We've got negative 2 and positive 2. All right? So to say that the answer to x squared is 4 is x equals 2 only really captures one of those 2 x-intercepts, and it misses that second solution. Right? So graphically we can see that the 2 answers should be plus and minus 2. Same idea for solving x squared equals 100. Based on the definition of square roots, there are 2 answers that make that equation true, either positive 10 or negative 10. And then similarly, if I looked at the parabola that goes along with this, if I put this in standard form, x squared minus 100 equals 0, and then I look at the x-intercepts of that parabola, y equals x squared minus 100, you're going to see that there are two of those at negative 10 and also at positive 10. Now what about square roots of negative numbers? So we may encounter these as we're solving equations. So based on the definition, the square root of negative 16, that should be a number so that when multiplied by itself, it equals negative 16, or a number that when squared equals negative 16. Right? So if you're thinking, at least 4 times 4 would give 16, all right, well then that would give positive 16. If you make those negative, right, because it's got to be a number multiplied by itself, then that would still give positive 16. Right, so it turns out there's no number, no real number, that when squared or when multiplied by itself will equal negative 16. Right? And similarly, here's another example, the square root of negative 1. What number squared gives negative 1? Well, any number squared is going to be positive, not negative. Right? So there's no real number that could be the square root of negative 1. So we can look at the connection again to the parabola that goes along with an equation like this, x squared equals negative 16. Right, so to solve this, this is what we just looked at. What number squared gives negative 16? And we're saying there's no such real number. If we put this in standard form, this would be x squared plus 16 equals 0. And what I'm now doing is looking for x-intercepts for the parabola y equals x squared plus 16. All right, so here's the graph, and you can see that this parabola lies entirely above the x-axis, so it doesn't actually have any x-intercepts. So that supports the idea that there's no real number that is the square root of negative 16. However, if we're still interested in a solution for that type of a problem, we can expand our definition of numbers to include imaginary numbers, and then we can talk about solutions. Right, so we have a definition. This is sort of the most basic imaginary number. We define the square root of negative 1, or in other words, the sort of like the first of the negative integers. We define its square root to be the imaginary number I. And then you can see if we were to square both sides of this, that would mean that I squared equals negative 1. Right? Or in other words, by definition, by saying that I is the square root of negative 1, I'm saying that I is the number that when squared is negative 1, or I is the number that when multiplied by itself will equal negative 1. And of course it's imaginary, it's not real, but this allows us to then work with other square roots of negative numbers. So for example, the square root of negative 16, I'll return to this one. Right? I can write this as square root negative 1 times square root 16. And now by definition, the square root of negative 1 is I, and the square root of 16 is 4. So this would be I times 4, and then just like with the variable x, we normally write the 4 before the I. So this would be 4i. Another example, the square root of negative 25. This would be the square root 25 times the square root of negative 1. Then square root 25 is 5, and square root of negative 1 is by definition I. And then finally one other example, square root negative 3 is square root negative 1 times square root of 3. Square root of negative 1 is I, and then square root of 3 can't be simplified anymore. So I would write this I square root of 3. So in general, integers like 4 or 5 will go before the I. square roots multiplied by I will come after the I. And I said that was the last example, but I did think of one more that I should really do here. So what about the square root of -8? All right, so this would be square root -1 times square root 8. And square root -1 is I. And then square root of 8 can be simplified further. So that would become square root 4 times square root 2. And then I've got I, and then the square root of 4 is 2. And square root of 2 is fully simplified. All right. So the order for these things, the 2 would go in front of the I. So integers go in front of I. And then square roots go after I. So this would be 2i square root of 2, and all three of those things are multiplied together. All right, so that gives a definition for square roots, a definition for imaginary numbers, and also shows you how to simplify square roots of negative numbers. In the next video, we will apply all of this to solving quadratic equations using square roots.